I hope everyone had a wonderful spring break, and welcome back to e-learning. This is Mr. McLaughlin again. We are in our third e-learning activity here for Algebra 2 College Prep. We're still in Chapter 11. We're going to have a nice review over data analysis and statistics. We'll start with 11.1, see a little graphical representation of data. If you remember, we were doing before the spring break, we were taking a look at different ways to display data or show a sample space and try to do some mathematical calculations of that data. But before we get back into that, let's do some of those nice SAT practice problems. I got 4 of them here for your belt work. So if you can hit the pause button and try those 4 problems, come on back in about 5 minutes and we'll go over them. See how you did at your answers. Well, welcome back. We'll go right to number 1 here. Number 1, the answer for that question is D. That's 4. If you notice what they're trying to get you to do here, they're trying to get you to find B over A. So if we start off with the equation that was been given to us, 2A over B equals 1/2. What you need to do is you need to get the B up on the top and the A on the bottom. So we got a little bit of a cross multiplication problem here, if you will. So if I cross multiply with 1 times B, I'll get B. And if I cross multiply with the 2A times the 2, I'll get 4A. Now again, our equation has to end up with B over A, so if you take the right side of the equation, you divide each side out by the value of A, using our division property equality, we'll now have a nice looking ratio, B over A, set equal to a value of 4, which makes that a nice proportion. So B over A is 4, and the answer should be D. If you slide to the upper right-hand corner, that answer for that question was C there. Now, first thing about this one is they give you the right word immediately when you think about slope. It dropped. Oil and gas production dropped, so that's going to be a negative value there. Biggest thing we'd like to think about this problem is as a linear equation, the model here that they're giving you, again, if you look at all your answers, they're all trying to get you a function with respect to time of how oil and gas production in a certain area dropped over about a 13-year span. So order of pair number 1 would be the year 2000 with 4 million barrels of oil and gas being produced. And then order of pair number 2 would be what happened over a 13-year time period. In the year 2013, the value dropped considerably from 4 million down to 1.9 million. What you need to do now is calculate the slope of that change in oil and gas production. So our classic model for slope, if you don't mind, I'll put it up here at the top. We'll get the change in y's going, so 1.9 minus that 4, and the change of time, 2013, going back to the year 2000. So right away, that would give you the value of negative 2.1 over 13 for your slope. So we can't write fractions with decimals in them. If you notice up here in this numerator here, we got a negative 2.1. So you can use your calculator and math frac that. If you do math frac it, or you just multiply the top and bottom by the value of 10, we'll get that thing to be decimal free. So our value for slope, or change in our oil and gas production, is now negative 21 over 130. And if you notice, there's only one value that has that negative slope right there in letter C. If we put in the slope-intercept form, which would be y equals 2 mx plus b, then our value with that function would be negative 210 over 130 times the x. And this started back in the year 2000, where there were 4 billion barrels of oil and gas being produced. So that would model a nice function over time. F of t could be substitute for y. Jump down here to question 3. There's your function notation. And if you notice, they're giving you 2 functions. So if you don't mind, I'll call the first one g of x there. Circle that in good old blue. Circle the second one here in red. And they're asking you to find out what h of 0 is. So if you think about what h of 0 is, that means to go to the function of h and plug in 0. So if we do that, that would now produce 1 minus g of 0. And if we think about what g of 0 is there, that 0 a little bit neater for you. G of 0 now has to come from the blue function. So we have to find out what g of 0 is. So my g of 0 value now turns into 2 times x. And again, x is taken on the place of the numerical value of 0 minus 1. So g of 0 now is equal to negative 1. So now we take that negative 1 and we put it right in there. And if we do that, now we have a function called h of 0, which is 1 minus g of 0. And if g of 0 takes on the value of negative 1, we got our double negative rule. 1 plus 1 there gives the value of 2. Answer for that one should be D. And the final one here kind of would be that bubble in response of the SAT portion of the test, where they just ask you to find out an answers, and there's no A, B, C, or D choices. So if we take a look at this equation, x squared plus x minus 12 equals to 0, this goes back to the first semester in your mathing technique. And hopefully you got some good mathing strategies and factoring in your brain there of what to do with a trinomial. So we're looking for numbers that multiply to be negative 12 and then add up to that middle term of positive 1. Everyone knows x times x is how you get x squared. A couple different ways to get negative 12 in math, but remember, we get that negative 12, so it adds up to be that positive 1, you get positive 4, and a negative 3 there. But now we want this function to equal to 0, so if we say what numbers can go into the binomials that make it equal to 0, and the first one, negative 4, would make that become 0, and the second would be positive 3. So those would be our two answers there for this equation. But if you notice, it says A is a solution, and A has to be bigger than 0. That means our answer has to be positive. And of course, we're looking for a positive answer. Negative 4 would not fulfill that. So we'd say the value of A in this problem, where A is a solution, A is represented by the x value of 3. That would be bubbling in 3 on my SAT bubble form. All right, so what we want to do now is just kind of go back to what we were doing in the first two E lessons, which were just kind of analyzing data, taking a look at different ways to represent data. And here we're trying to put it on the classic circle graph. So check out your circle graph and notice that they have broken down the circle into 5 distinct areas. They asked people a simple question: what is your favorite sport to watch? And you can notice 37% said they like to watch football, 13% for basketball, baseball got 12%, auto racing 5%, and then other sports not including football, baseball, basketball, auto racing, some other type of activity that would be considered a sport. So if we just check out question 12, it says what percent of the people surveyed named football or basketball? All right, so if you don't mind, I'm just going to kind of go up here and put that one down. We're looking for the percent of people that answered the question and said that they liked football, or the percent of the people that said they liked basketball. So if you don't mind, I'll go basketball for BB. So for this one, remember what the word or means. Or in the land of word problems that involve percents and probability is the operation of addition. So our football fans surveyed were at 37%, and our basketball fans were at 13%. So that means 50% of the people surveyed either liked basketball or football as their favorite sport to watch on TV. Jump down there to question 13. And question 13, this is kind of what we call the complement when we are doing chapter 11 with probability. It says, what percent of the people surveyed did not name football as their favorite sport? So if you remember, first of all, the probability that we liked football was 37% of the people surveyed said football was their favorite sport to watch on TV. So now if we go the probability or the percent of not liking football, then we'd say that would be the complement of that, which which would be 100% minus 37%. So simple subtraction here would tell us that that value turns out to be 63%. So 63% of the people surveyed did not choose football as their favorite sport to watch on television. And then question 14 down here, I want you to now get into a specific sample space. They're simply telling you that, let's pretend 200 people were asked this question, what was their favorite sport to watch on television, and the percentage were given to you. I want you to make a nice little chart, and then I want you to put that in a bar graph. So it's a nice little connection of trying to display our data. So for me, if we wanted to turn this into a simple chart, I would just write down the word sport, and then I would write down the word people. And we can make our classic 2-column chart there. So I'll use FB again for football. And out of 200 people, if we were talking about 200 people surveyed, and we know from football 37% of the people surveyed like it, we just multiply the 200 by the 0.37. And that would give us 74 people out of the 200 said football was their favorite sport. I'll use double B for basketball and just kind of go in order here. Same idea, we're going to take that digit 200, and we got 13% of the people surveyed saying basketball was their favorite sport to watch on television. So 200 times the 0.13 should get us to 26. And then for baseball, I'll go BSB, baseball people. Again, 200 people surveyed in our baseball category. We're at 12%. So 200 times that 0.12 is 24. How about AR for auto racing? A lot of auto racing fans out there. Once again, we sampled 200 people what their favorite sport was to watch on television. And our auto racing people came in at 5%. Remember, 5% is a decimal, is 0.05 there. So if we take the 200 and we multiply it by the 0.05, that's going to get us 10 people that chose auto racing as their favorite sport to watch on television out of 200. And then finally, our last category would be another sport. I don't know, maybe like hockey, maybe lacrosse, maybe one of those other sports that are out there. Others was 33%, so that was the largest chunk of all of them, I believe, besides football, right? Football was up there at 37%. So 33% said other. That means 66 people out of 200 chose a different sport, football, basketball, baseball, or auto racing that they like to watch on television. Maybe they like to watch golf or something. All right, and now I want you to go back to bar graphs here for part B. So if I was going to put this on a bar graph and just kind of do one the old-fashioned way, I kind of do my first quadrant here. And look at our numbers that are in our table that we just made. Smallest number is 10, largest number is 74. If we just went by tens here, try to make equal spaces, 10, 20, 30, 40, 50, 60, 70. And probably one more notch to get up to 74, but we could kind of make that fit. And remember what a bar graph looks like. They have individual categories, and kind of when you do a bar graph, you're going up to a frequency idea, how many people like that activity. And then for my x-axis, I would just kind of chop them up the same way with our individual sports. So I'll just kind of try to keep these bars equal. So the first chunk would represent the football. Second chunk there is going to go with my basketball. Third chunk is my baseball. Finally, my auto racing, and then people that chose the others. Just trying to construct a bar graph and being a little bit accurate here is all we're looking for. A good way to display data is on a bar graph. So we had 74 people out of the 200 that liked football. So again, if that's 75 right there, maybe just a smidge lower. And then I like to kind of shade in my bars here. Give them a little bit of a shaded area there. Pretty big bar. believe will be the biggest bar of all of our data. Baseball goes all the way down to 26%, so again, right between 20 and 30. 26% in the basketball area there, basketball, BB. Our baseball area is at 24, so just a smidge below that, not much at all. So our baseball area represented a bar graph would just be a smidge less than the basketball players. Go over to our auto racing, 10 people there. 10 people like auto racing out of our 200. And then the other, way back up there to 66. So, of course, kind of estimate where 66 is, somewhere between 60 and 70. And my best approximation, probably a little bit too big there. Maybe a smidge big. But right about 66. I think I'm pretty good there. And those are our others. And once again, we're looking at a sample space of 200 people that were asked the question, which is their favorite sport to watch on television? And you can definitely say football's number one. Auto racing, of course, would be the last one. And then a big chunk of people that liked the other sports. All right, well, I hope you guys are all doing well out there and you're enjoying your e-learning activities. If you flip the page there, I hope it's all in place for you, but we got a nice little worksheet for you with some line graphs and some tables and some charts, and hopefully, of course, maybe in a little scatter plot over there. So if you could do that assignment and send me a picture of it, email it to my email address. And you guys stay well out there, and we hope to see everyone soon.